Hello wonderful person, this is Anton, and in this video we're going to be talking about yet another unusual neutron star slash pulsar in our galaxy, and it's this star right here. And just by looking at it, it might not actually look that unusual, but today you're going to learn a little bit more about this and why this is actually one of the most rare objects in our galaxy. Welcome to What the Math. So first of all, this is a neutron star known as RX J0822-4300. You can actually find it in Space Engine by typing the actual name, and just by looking at it from a distance, it doesn't really look like anything special, and that's because you can't really tell how fast it's moving. Unofficially, it's known as the Cosmic Cannonball, because, as you can probably imagine, it is actually moving ridiculously fast. As of today, it's one of the fastest, if not the fastest objects, depending on when you're watching this video, in our galaxy, and its actual speed is about 0.5% of speed of light, which is about 1500 kilometers per second. In other words, it's actually flying so fast that it's going to actually shoot out of our galaxy in the next million or so years. It's going to become an intergalactic object. Now I wanted to actually show you where it's located and where it's coming from, because that's kind of important in explaining both the origin of this object, but also in trying to understand how it achieved this velocity. It's actually relatively close to a very well-known supernova, or specifically a nebula that was produced by a supernova, known as Puppis A. So here I am outside of our galaxy, and I'm going to show you how close it is to that other object. We're going to zoom in a little bit just so you can see, and we're going to type Puppis A in Space Engine, and right there, right next to it, is this Supernova Remnant. It is actually relatively large in terms of size. It's about 100 or so light years in diameter, and it's about 6,000 to maybe 7,000 light years away from our planet, but you can see it with a relatively powerful telescope. And if you were to trace the actual vector of velocity from the neutron star I just showed you, it would actually point almost directly at the middle of this particular nebula. So in other words, the supernova that most likely occurred approximately 3,700 years ago, and if you were to actually look at it with the telescope, it would look something like this, is responsible for creating not just this beautiful nebula, but also kicking out this particular neutron star that we're going to go back to out of our galaxy, essentially. Well, not yet, but in about a million years it's going to become an intergalactic traveler. Now, one of the reasons I actually wanted to mention this object is because in the last few months or so, from when I'm making this video, we actually discovered quite a lot of vectors of various hypervelocity stars. Basically objects that are moving faster than they should be moving and are either going to escape our galaxy or are basically on the way out of the galaxy already. And interestingly, what we've discovered is that we assumed that many of them were moving away from our galaxy, but it turns out that most of them are actually entering our galaxy. In other words, if you were to look at many of these hypervelocity stars, they're actually intergalactic travelers already. They're traveling between galaxies at ridiculously high speeds, and once in a while they might enter the Milky Way, but then will obviously not stay here very long and shoot out and continue on their merry way. And this is exactly what's going to eventually happen to the Cosmic Cannonball as well, with the basically record-holding velocity of 1500 kilometers per second, which is I guess about 1,000 miles per second. It's going to essentially become one of these intergalactic travelers and visit many galaxies in the future. But there is still actually a mystery about how this unusual pulsar achieved this velocity, and I'm going to try to show you what we think happened, but it still doesn't really make sense. And so our current assumption is that there was a very large star, very massive star, that basically went supernova and exploded with such an intensity that it kicked out the Cosmic Cannonball out of the star system, creating the beautiful nebula that we see, but also giving this object a tremendously high velocity. Let's actually initiate the supernova so we can see how all of this happens, I guess, in somewhat real time. But the problem with this particular theory is that if this is true, then this would make Cosmic Cannonball the only object known to us that is moving so fast because of the supernova projection. In other words, no other object known to us has such a tremendously high velocity due to a supernova explosion, because normally supernova doesn't actually accelerate objects to such an extent. So let's actually wait a little bit until we see objects flying away from this, because it's a little bit difficult to see due to the brightness of all of this, but it is currently moving at a relatively high speed that I gave it. But the only concern for us is that, well, if this is how it happened, we should actually see a lot more of these objects in our galaxy, but we have not found any. And the few explanations is that either this is actually not a neutron star as we thought before, but some kind of a very exotic object. Like, for example, maybe this is the hypothetical quark star and interacted with the supernova to such an extent that it accelerated to these tremendously high speeds. Or B is that it also somehow got slingshot by a black hole, which is typically how these stars get such high velocities. You do need to have a slingshot from a black hole for a star to basically move this fast. And so this is why we are not entirely sure about what's actually happening with this Cosmic Cannonball or the Puppis A supernova, or specifically Puppis A nebula. Mostly because, well, it's a very large nebula, much larger than we would expect from a typical supernova, but also the object itself is moving much faster. So something happened 3,700 years ago in this particular location that created these unusual conditions and made this object move that fast. And here, if I actually accelerate time a little bit, you can kind of see the neutron star, the Cosmic Cannonball, slowly moving out of this very large nebula. Now, what we actually discover in the future is still not entirely certain because, well, first of all, this object is kind of far away, so it's difficult to study what's happening there, but also because we haven't really discovered that many of these hypervelocity stars, and so we're not really sure how they even achieve these velocities in most cases. But as we discover more and more of these beautiful, unusual, and mysterious stars, especially stars passing through our galaxy, we might be able to actually come up with an interesting theory explaining how they achieve these large velocities. The current prevalent theory is that they normally pass relatively close to the center of the galaxy and get slingshot by the supermassive black hole in the middle. But if that's the case, that's not how it happened for this little guy. So we don't really know if this applies to all of the hypervelocity stars. For now though, that's all we kind of know about this object, and hopefully in the next few years we'll discover a little bit more about it. And as I do discover new things, I'm going to make a follow-up video explaining a few more things. If you've enjoyed this video, don't forget to subscribe, share this video with someone who loves learning about space and wants to learn through video games, and come back tomorrow to learn something else. And maybe even consider supporting this channel on Patreon, because it does help me a lot. See you guys later, space out, and as always, bye bye.